Hello, this week we're going to be covering the first three sections of Chapter 3. Chapter 3 is all about the coordinate system. The coordinate system here has an x-axis, a y-axis, and these axes are just number lines, where at the center you have 0, going to the right these are positive numbers, 1, 2, 3, 4, so on and so forth, -1, -2, -3, along this number line. The y-axis is just a vertical number line with positive numbers going up, negative numbers going down. The coordinate system is broken up into 4 quadrants. Area here is quadrant 1, here quadrant 2, quadrant 3, and quadrant 4. You'll always see them labeled with the Roman numerals like this. One special thing to note is that along the axes themselves, if you are on the axis, you are not in any quadrant. You have to be within that region to be within that specific quadrant. Also, that point right where both number lines are 0, that is called the origin. To actually use the coordinate system, we need points to plot. For example, 1, 3. This is called an ordered pair, where the first number is always your x, and your second number is always your y. It's an ordered pair because they're always in that order. So this ordered pair, 1, 3, we can plot that on the coordinate system by finding 1 on the x-axis, 3 on the y-axis, and finding where those two meet, right here. So you see here this point lines up with the 1 on the x-axis, the 3 on the y-axis, so that is the only point that fits for 1, 3. We can plot any ordered pair, say -2, 5. We just find again -2 on the x-axis, 5 on the y-axis, and plot the point right where those two line up. So if I were to plot a point here on the coordinate system right there, I can then find the ordered pair that is associated with that point. I find here 3 on the x-axis, -5 on the y-axis, so that is the point 3 for the x value and -5 for the y value, and that is my ordered pair for that point. Ordered pairs can also be written in a table where I have a column of x values, a column of y values, and they are associated horizontally here. So if I said I had an x value of 2 and a corresponding y value of 3, this is then my ordered pair 2, 3. Can throw in some more points here, say 3, 7, or -2, -3. I can then plot all the points in this table. 2, 3, I go to 2 on the x-axis, 3 on the y-axis, and plot that point. 3, 7, again 3 on the x-axis, 7 on the y-axis, and plot that point. -2, -3, I go to -2 on the x, -3 on the y, and plot that point. Next, let's make a scatter plot and a line graph. If I have my table of values here, x and y, and I have a bunch of points associated with that, say -2, 3, -1, 7, 0, 5, and let's do 2 and -2. We're going to go ahead and plot these points. So -2, 3, -2 on the x, 3 on the y, plot that point. -1, 7, go to -1 on the x, 7 on the y, and plot that point. 0, 5, again 0 on the x, 5 on the y, and plot that point. And 2, -2, 2 on the x, -2 on the y, and plot that point. Now this is what is called a scatter plot. It's plotting all of those points that you have in your table and just leaving them as it is, a bunch of points. A line graph, however, will connect the points in order. This is now a line graph because I have connected the points. And that is the only difference between a scatter plot and a line graph. Next, let's take a look at some equations and how they fit with the coordinate system. Let's take, for example, the equation y equals x plus 3. This is a linear equation in two variables, since it has an x and a y. Just like our coordinate system has an x and a y, this is set up to graph equations with two variables. We can check certain ordered pairs to see if they are solutions to this equation, and the goal is to plot all of the ordered pairs that are solutions to this equation on the graph. So let's go ahead and practice checking ordered pairs to see if they are solutions to our equation. So let's first check the point 1, 4. So remember, an ordered pair is always the x value first and then the y value. So we just plug that into our equation. Y value of 4 is equal to 1 plus 3. 1 plus 3 is 4, so 1, 4 is a solution to this equation. Next, let's check the ordered pair 2, negative 3. So again, this is my x value, my y value. So I plug in negative 3 for y. It's equal to 2 plus 3. Negative 3 equals 5? I don't think so. So 2, negative 3 is not a solution to this equation. Lastly, let's check the point negative 3, 0. So again, plug in 0 for y, negative 3 for x, plus 3. Negative 3 plus 3 is 0, and I have 0 equals 0. So this is a solution. So we have here two solutions to our equation. Let's go ahead and graph those 2 points now. So we'll start with plotting the point 1, 4, right here. The point negative 3, 0. Negative 3 on the x, 0 on the y, so right here. We can even arrange this information in a table. Our x and our y's are solutions. Right? We'll have 1, 4 as a solution, negative 3, 0 as a solution, and we can find many more. As a matter of fact, we can find infinitely more. With any linear two-variable equation, we can find infinitely many solutions. What happens is those solutions tend to fall along a very specific line. When I connect those 2 points that we plotted with a line, that line will represent all of the possible solutions to this equation. So if I find any point along that line, say right here, this is the point 5, 8, right? I can then go ahead and check that point 5, 8 as a solution. I plug in 5 for my x, 8 for my y, and indeed 8 does equal that 5 plus the 3. So this is a solution to the equation, and you can check that for any point along this line, and it will be a solution to your equation. So that's one great thing about equations. All you have to do is find 2 solutions to the equation, and you can then plot that graph for that equation just by connecting those 2 points with a line. Then everything else on that line will also be a solution. Let's go ahead and now make a table of solutions from a given equation. Let's use 5x plus 2y equals 10. We'll go ahead and keep track of our table over here, our solutions to our equations. The easiest way to make a table is just to start picking numbers for one of your variables and then plug that into your equation and solve for the remaining variable. So let's go ahead and start with negative 2 for x, and we'll go ahead and solve for y. So I plug in that negative 2 for x. I have 5 times negative 2 plus 2y equals 10. I multiply, so I have negative 10 plus 2y is equal to 10. I add 10 to both sides now to get that y by itself. I have 2y equals 20. Divide by 2, and we have y equals 10. That is now our y value for our x equaling negative 2, so we plug that into our table, and we have one solution to that equation. Next, we want to pick another number for x. Let's go ahead and plug in 0 this time. So I plug in 0 for x. I have 5 times 0 plus 2y equals 10. 5 times 0 is 0, so it's now gone, and I'm just left with 2y equals 10. Divide both sides by 2, and y equals 5. Go ahead then and plug that into our table, and we have a second point that is also a solution to that same equation. Next, let's go ahead and plug in the number 2 for x, and then again we'll solve for y. So we have 5 times 2 plus 2y equals 10. So I have now 10 plus 2y equals 10. I subtract 10 from both sides, and I have 2y equals 0. Divide both sides by 2, and you have y equals 0. So we'll plug that into our table. So we have now 3 points. Let's go ahead and plot these 3 points and make sure that those 3 points give us a line on our coordinate system. Let's plot our points. -2, 10. So -2, 10. We have a point right there. 0, 5. Point right here. And 2, 0. Another point right here. We'll go ahead and connect those points with a line. So right straight like this. And indeed they all do match up. We can then carry out this line along that same pattern, and it will go along in that same direction forever. So this line goes off up and to the left forever and down and to the right forever. This graph helps lead us into our discussion of x and y intercepts. An x-intercept is just the point of the graph that crosses the x-axis. So this right here, this point, is our x-intercept. That point, we'll recall, is the point 2, 0. An x-intercept, since it is on the x-axis, always has a y value of 0. As we see here in our table, the y value is 0. On the other hand, the y-intercept, where the graph crosses the y-axis, this point right here, that point always has an x value of 0. We see that point right here on our table, 0, 5, our x value is 0. So we have both of our intercepts here, our y-intercept where x is 0, and our x-intercept where y is 0. Again, those intercepts are the points that cross the x or y axis. So we have our y and our x-intercept. We can easily find the intercepts in an equation. For example, -4x plus 5y equals 20. We can find the intercepts by plugging in 0 for one of the variables and solving for the remaining variable. So if I want the y-intercept, I plug in 0 for x. So -4 times 0 plus 5y equals 20. -4 times 0 is 0, so I just have 5y equals 20. Divide by 5, and we have y equals 4. This gives me the y-intercept of 0, 4. If I want to find the x-intercept, I can do the same thing now, just plugging 0 in for y. So we have -4x plus 5 times 0 equals 20. 5 times 0 is 0, so I have -4x equals 20. Divide by a -4 from both sides, and x equals a -5. So my x-intercept in this case is -5, 0. And these are my two intercepts for this equation. I can then graph this equation using just the intercepts. So we plot our 2 points, 0, 4 right here, and -5, 0 right here. And then we connect those 2 points with our line, right like so. And again, this line goes on forever in both directions. Next, let's take a look at some special cases, horizontal and vertical lines. Say I have this equation y equals 5. Since this is a linear equation with only one variable now, when we go to plot it on our axis, since there is no x in the equation, it will not change as we move along the x-axis. So let's go ahead and write out a table real quick. Say I have my x and my y here. If I wanted to say plug in -2 for x, since there is no x in here, y is still just 5. If I plugged in try 0, Again, there's no x, so y is 5, and you see this pattern continue no matter what I plug in for x, y is always 5. So if I plot those points, -2, 5, I get this point here, 0, 5, this point here, 1, 5, okay, no matter what, y will equal 5. So what I end up with is a horizontal line through where y equals 5. And this is my graph. It's a horizontal line, the y-intercept of 0, 5, and we see it does not change as it moves along across the x-axis. It just stays flat, just like that. If instead, say we had the equation x equals 3, again, there's no y, so it doesn't matter what I plug in for y, x will always be 3. So if y was 0, x would be 3. If y was 6, x would be 3. If y was -5, x would still be 3. So what I end up with in this case is now a vertical line going through where x equals 3 on my graph. So we have a vertical line when we have x equal to some number, and we get that horizontal line when we have y equal to some number. So if I have this line right here, this horizontal line, I can then identify the equation associated with that by recognizing, well, it's a horizontal line, so it's going to be y equal to something. And in this case, it goes through -4, so y equals -4 is my equation for that horizontal line. If I have, say, this line here, I see that it is a vertical line, which means it will be x equal to something. It goes through the point 2 on the x-axis, so it's x equals 2. So x equals 2 gives us this vertical line, y equals -4 gives us that horizontal line. And that will cover it for the first 3 sections of Chapter 3. Next week we will take a look at the last 4 sections of Chapter 3 and get much more in depth with graphing. Until then, be sure to check out the homework and the quiz for this sections and have them done by the end of this week. Also, if you have any questions, feel free to ask them in the discussion board.